Hi students, welcome back. In this week's video, we're going to learn how to use the sine rule. This video is divided into two parts. The first part of the video, I'll be offering the concepts of the sine rule and some examples of how we can apply the sine rule. The second half of the video, we'll be doing some problem sums where we can learn how to effectively apply the sine rule. So stay on. Right, let's do some recap. It is important that we are able to label the angles and the sides opposite the angles correctly. It's very important so that we can use the formula effectively. Let's look at some triangles. Right, supposing if I label the angle, usually the angle are labeled as uppercase, and the sides that's opposite the angle are labeled as lowercase. So in the example there, if I label the angle as A, then the side opposite the angle A will be labeled as lowercase a. Right, let's look at another example. And the last one. Alright, so to summarize, the angles are usually labeled using uppercase, uppercase, and the sides opposite the angles are usually labeled in lowercase. Right, so the sine rule is actually derived from the formulas to find the area of a triangle. If you have not remember, let's do some recap. Right, so if you're given a triangle with two sides labeled as the A and B and the angle C, do you remember how the formula looks like to find the area of this triangle? Yes, it will be half AB sine C. Let's do another triangle, the same triangle, but in this case now, I'm not going to use angle C. Let's say if I'm given angle A, then how would the formula looks like? Yes, it will be half BC sine A. And supposing using the same triangle, I'm not given angle A or C, but instead I'm given angle B and sides A and C. What would the formula looks like? Yes, it will be half AC sine B. Right. So since we're talking about the same triangle, whichever formulas that we use, the area will be the same. Right. It's just like me weighing myself, using the same weighing machine. If I were to weigh myself in Clementi or in Jurong or in other parts of the country, it would be the same weight, right? So likewise, since we're talking about the same triangle, if we used half AB sine C or half BC sine A or half AC sine B, the values will be the same. So the next question is, from these equations, how am I able to derive the sine rule? And what is the sine rule? It's just basically sine C over C equals to sine B over B equals to sine A over A. Right, so let's put on our thinking cap and see how we can actually derive this formula from your half AB sine C equals to half BC sine A equals to half AC sine B. Right, so have you managed to bridge the gaps? That is to do some manipulations from your half AB sine C equals to half AC sine B equals to half BC sine A to derive the sine rule? If not, let's do it together. Right, So if you look at the equations, half AB sine C equals to half AC sine B equals to half BC sine A, you'll see that half is actually the common fractions that appear in all. So what we're going to do is we're just going to divide it by half throughout, and let's see what happens. Yes, the half will be cancelled off because basically half divided by half will gives you 1. So that will end up getting AB sine C equals to AC sine B equals to BC sine A. Right, so the next thing is that if you were to recall the formulas for the sine rule, it's something like sine C over C equals to sine B over B equals to sine A over A. So that gives you an idea that we have to get rid of things like AB, AC, and BC. So how effectively we can actually get rid of all this? That means AB, AC, BC. What is the common multiple of these three terms? Right, that will be ABC, right? So we're going to divide every terms with ABC and let's see what happens. Yes, you will see again there will be some simplifications that can be done. And ta-da! We have just got the sine rule. Right, that is sine angle C over C equals to sine angle B over B equals to sine angle A over A. Right. So to remember this formula, this is how you can remember it. If you're given the angle B, then the sides that's opposite angle B will be, you can just draw an arrow. Right. And if you're given angle A, the side that's opposite angle A will be this. Angle C, the side opposite angle C will just be the lowercase c. Okay, this is how you can learn to remember the formula. Okay, right. Right, so let's do a summary on the sine rule. So basically the sine rule, it's a ratio. We're comparing the ratio. That means if you take the values of sine C divided by C, you actually get a value. And this value is equals to the ratio when you get sine B divided by B or when you get sine A divided by A. Right. So the question is that is there another way of writing this formula? Because if you don't want to write it as sine C over C equals to sine B over B equals to sine A over A, then is there another way of writing it? And the answer is yes, you can write it as, because since you're comparing it as a ratio, you can actually write it as C over sine C equals to B over sine B equals to A over sine A. Then the next question is that, then can I do it the another way? That means, can I just simply write it as C over sine C equals to sine B over B equals to A over sine A? Then the answer is no. You can't do it this way, okay? It's a no. You can't do it this way, right? Because you when you're talking about sine C over C, we're actually equals to sine B over B equals to sine over A. We're actually comparing ratio, and if you're comparing ratio, then you have to make sure that the numerators over the denominators, you are actually comparing it correctly. Okay. So the uppercase ABC will represent the angles in the triangle, and the lowercase ABC will represent the sides of a triangle. So we need to get this concept correct so that we can apply the formula correctly and effectively. Alright, let's put our knowledge into practice. Let's look at this question. So in this question here, let's look at what we are given. So we are given a triangle and some angles, like angle B is 58.3, angle C is 39.4, the length for BC is 12.5. And then what are we supposed to find? Yes, we're supposed to find angle A. Right, so if you look at angle A, basically it's just another angle in the triangle. And we all know that all these three angles will end up to be 180 degrees, right? Sum of angles in the triangle equals to 180. So basically, we don't even have to apply the sine rule yet. In part I, we just take 180 minus 58.3 minus 39.4. to get our angle A 82.3 degrees. And why do you think they act? Why do you think the first part is to find angle A? Correct, because to apply the sine rule effectively, in part 2, you're supposed to find the length of AB, right? So to find the length of AB, which angle will we be using? So if you're going to find AB, then draw your arrow. We will have to use this 39.4, right? And you are only given one side, that it's BC, which is 12.5, and the angle that's opposite 12.5 will be your angle A. So that is the reason why in part I, the questions actually give you some scaffolding, ask you to find angle A. So most of the time, the parts of the questions are related to one another, and finding one part will lead you to find the second part. Okay, let me erase off this thing. Yeah, okay. Right, so we're going to label AB at lowercase c because it's opposite angle C, and then we're going to yes, fill up angle A where we have found earlier on to be 82.3. And if you were to draw the arrow, okay, this is what is happening. Yep, and we can just write down the formula. The formula would be, okay, in the formula given earlier on, we're given this, we have found this, right? This sine formula, the sine rule. All right, so it's not necessary to use three ratios at one time. You can just choose to use two of them. It can be sine A over A equals to sine B over B. In this case here, okay, I'm using the ratio for sine C over C equals to sine A over A. Okay, so at any one time, you just need to use one pair. Okay, you don't need to use all three of them. Basically, you can't. You just can't use. Hey, why I cannot erase it? Hello, I want to erase this. Yeah. All right. So so the next step is, yeah, we just fill in the value for the angle C, which is 39.4 over C, which is actually the length of AB. I should have just removed it and filled it up with AB. It's easier. Angle A is 82.3 over 12.5, and we're going to apply a shortcut here, which is going to use this shortcut called the cross multiply method, where I'm just going to take C multiplied by sine 82.3 to gives you the other direction, which is 12.5 times sine 39.4. Okay, this shortcut is very useful when you apply the sine rule. Okay, and then to find the values of C, you just basically divide both sides by sine 82.3, and we get the answer for the length of AB to be 8.01 centimeter, right, expressed to three significant figures. So that's how we find the length of AB. So actually, to be what do you call that, more professional, right, you can just put AB is approximately equals to 8.01 cm. All right. Oh, okay. I did do it in the last part. All right. Okay, so that's erase of this. Okay, that's how we do part I and part 2. Right, let's look at part 3. So for part 3, we're supposed to find the length of AC, right? So I'm going to label the length of AC as the lowercase b, because that is the side that's opposite our angle B, which is 58.3. And then we have already found angle A to be 82.3, and the side that's opposite angle A will be the lowest case A. So the formula will just be sine B over B. Oh, okay, sine A over A equals to sine B over B, right? Or you can write sine B over B equals to sine A over A. You will still get the same answer. So now let's substitute angle A to be 82.3 and the sides A to be 12.5, angle B to be 58.3, and B to be the side AC. Because I just realized that there's no point, doing extra steps by you just substitute the lowercase b with the actual sides that we are finding. That will save you um, the energy of having to write the last statement there for AC equals to blah blah blah. Okay, so we're going to use the shortcut, right? So the shortcut is just cross multiply. I'm not too sure if you were to remember how the shortcuts it's been derived of. Just very, very quickly give you an example. Let's say if you have x over 2 equals to 4 over 5, right? So to find the values of x, you have to multiply by 5 first on both sides, remember? So that you will have 5x over 2 equals to 4, and then to get rid of this 2, you times the 2 again on both sides, and finally you get 5x equals to 8, right? So the shortcut is basically just do it this way. Okay, we do the other way first because you want to find the values of x, right? So it's just basically 5 times x gives you 5x equal, then 4 times 2 gives you 8, which will get the same answer as what we have done early on. If you were to do it, carry out the steps diligently, right? I multiply by 2 first, to multiply by 5 to get rid of the 5, and then multiply by 2, so on and so forth. Okay, right. So I'm going to just erase this off. Okay, so let's apply the shortcut. So that will give you AC times sine 82.3 equal to the other one, which is 12.5 times sine 58.3. Make sure you put your equal sign here. Okay, the equal sign must be there. Otherwise, it does not make sense. And then the next thing is to divide by sine 82.3 on both sides. And you get AC to be 10.7 centimeter expressed to 3 significant figure. So not too difficult, right? Alright, let's look at another example. Basically, it's slightly different from the earlier one. The earlier one, we're actually given two angles. If you were to remember, two angles and one side. Here, you're actually given two sides and one angle. And this angle, it's not the included angle, right? This angle is not the included angle. What is an included angle? Just give an example. Okay, if you're talking about this side here and this one here, the angle that's wedged between the two sides that are thicken it, it's called the included angle. It's basically the angle that is wedged between the two sides, the two intended sides. So here, this is not, okay? This one is not. So this is 42 degrees is not an included angle. All right. Okay, so what are we supposed to find? We're supposed to find angle R. So angle R, I want to erase this. Okay, so angle R will basically, it's an angle that's opposite 10.2, and your 42 degrees, which is your angle Q, it's opposite the side PR. Okay, right. So if you were to recall, the formula is sine A over A equals to sine B over B. So you just basically replace your angle A with R, sine R over R, and then your angle B with the letter Q, because the angles ABC are just any variables that you can you use to label the angles in the triangle. So if you do not like to call it ABC, you can just call it PQR, STU, DEF, XYZ. All right, the result is the same. Okay, so what we have will be sine R over R equals to sine Q over Q, and that's angle R. It's the one that we're supposed to find. Let's submit the values for your sides. R, that's 10.2, Q 42 over 12, and let's do a cross multiply. Right. Okay, right. So in this case here, we have to find the angle R. So therefore, we have to apply sine inverse. Okay, let's do another recall. Supposing if you have sine A equals to 0.5, okay, so to find angle A is just sine inverse 0.5. And if you use a calculator, this is 30 degrees. Right, so for angle R, will just basically be sine inverse 0.5688. And for angle, you need to express it to one decimal place for the final answer. But you see that I actually have one that is more than one decimal places because I may need the answer for some other calculation. Okay, right. Let's look at part 2. Yeah, so since I've already found angle R, then basically angle P will just be 180 minus 42 minus 34.667. Okay, angle R will just, if you fill that in, this is 34.667, right? And that gives you 103.3 degrees. For angles in degree, it should express to one decimal place for the final answer. So part 2 is relatively easy. Okay, so for part 3, we are asked to find the values of RQ. So let's fill in what we have found earlier on. We managed to find the angle P, which is 103.3333. Right, so the sides opposite angle P will just be the lowercase p. And then we can use the angle 42. Right, so in this case here, the formula will be sine P over P equals to sine Q over Q. Okay, so you just fill in the necessary data. Then from there, you can do a cross multiply again. Divide by sine 42 on both sides, and you can find RQ to be 17.5 cm. Okay, right, I think it's time now for you to try to do a questions on your own, right, to see if the lessons have actually helped you to understand the sine rule and actually help you to know how to apply the sine rule effectively. So what I have here is the questions for you to try, and I'll be giving you the answers, and you can just try it out. And if you do not get the answer, you can just send me a message. Yep, okay. So try it, don't give up. Right, let's look at these questions. This question is rather interesting. All right, why this is interesting? Okay, you're given the triangle ABC. You're given ABC is 55, AB is 16.3, AC 14.3. You're supposed to find angle ACB. So why do you think this question is interesting? Yes, it's interesting because the diagram is not given to you, and therefore you can actually unleash your creativity to draw the diagram. Right, so we all know the angle ACB, because it's not given to you, it could be an acute angle, it can also be an obtuse angle. So let's see what happens if angle ACB is an acute angle. All right, so this is what will happen when the angle ACB is acute. All right, with all the dimensions given. Now, so imagine the point A, it's the center of a circle. All right, I've just drawn the circle. Point A is the center of the circle, and then your AC is actually the radius of the circle, which is 14.3. So I can actually draw another radius, right, from A. And in this case here, what happened? Yes, you see that the angle ACB can also be an obtuse angle. Right, so this question is interesting in the sense that there are two possible answers for ACB. Okay, one possible is the angle ACB is an acute. The other possible angle is when it's an obtuse. Because your 14.3 is the radius of a circle with center A. And that's the reason why we can have two different diagrams for these questions. Right, so let's solve these questions. Okay, so earlier on, we have all agreed that there's two possibility. Your ACB can be acute, your ACB can be obtuse. So let's look at what happened. Okay, we're going to use the blue triangle when your angle ACB is acute. So what kind of the answer we'll get for the angle ACB? Right, so that's the angle we're supposed to find. Okay, so first thing first, let's label all the sides properly. So I'm going to label the angles as all uppercase and then the sides as lowercase. Okay, and then I'm going to write down the formula. In this case, that I have I'm given angle B, okay, and I'm given the sides B. I'm given a side C, and I need to find angle C, right? So the formula will be sine B over B equals to sine C over C. So that's put in the data. So angle B, it's 55 degrees as given in the questions, over 14.3, and then C is referring to the angle ACB. So that's put in the correct labeling. So that will be sine angle ACB over 16.3. And then we're going to do a cross multiplication, a shortcut. But basically, you just take 16.3 multiplied by sine 55 to get this. And then the equal sign, it's in the middle, no change. And the other one is just taking, oh, sorry, I think I did it at the wrong side. So because we're supposed to find sine ABC, right? So let's take this one, multiply with 14.3 and put it on the left hand side. Okay, usually whatever you need to find, we just put it at the left hand side. Okay, so the equal sign remain the same. And then the next thing is that you just take 16.3 multiply with sine 55. That's how we get this part here. All right, and then the next step is we're going to divide everything by 14.3. Okay, because I need to find sine angle ACB, the subject of the equation, right? And you can just use a calculator to work this guy out, which come out to be 0.9337. Right, please use at least 4 decimal places, okay, or 4 significant figures, okay, for the intermediate answer. So to find angle ACB, you just need to sine inverse 0.9337. Yes, and then we'll get the acute angle to be 69.0. All right, so the degree of accuracy for the angles should be 1 decimal place for the final answer. All right, so this is how we solve the questions when the angle ACB is acute. So what happened if the angle ACB is an obtuse angle? Let's look at it. Right, so what we're going to do is, instead, we're going to use the yellow triangle, the yellow color one. Yes, that will be the triangle that we'll be focusing on, right? Yes, and that will be the angle that we're looking for, right? All right, why do you think I highlight the pink color triangle? Yes, because you will see that what happened here, it's AC, this triangle here is actually an isosceles triangle, because both we have AC. AC is the radius of the circle, remember from the earlier diagram. So we will have the pink triangle as a isosceles triangle. Therefore, this angle theta that labeled on the diagram, it's also 69.019. Okay, and the obtuse angle ACB will just be 180 minus 69.019, which is 111.0 degrees. So for this particular questions, right, if you only give one answer, which is 69 or 111.0, then your answer will not be complete. Okay, for this, because for these questions, it is possible to draw a acute angle triangle for ACB and an obtuse angle ACB. So therefore, you're supposed to get two answers, one which is 69.0 and one is 111.0. All right, now let's look at another questions. So for this questions here, we're given a triangle and you're given that QR is the longer side and has a length of 8.2. PR is 5 centimeter. Angle PQR is given to be 26 degrees. So we are asked to find angle QPR. Okay, so basically we are asked to find this angle. Right, and also the length of PQ. So in these questions have two things you need to find angle QPR and also the length of PQ. So first thing first, let's label the angles and the sides properly. All right, you see that I'm using 26 is because if you were to draw the arrow from 26 to the opposite side, you see that I have both values given. I have the angle and I also have the sides. All right, so that's the reason why I'm using the pair. And of course, I need angle QPR. Okay, so the next thing is to write down the formula, which is sine B over B or sine A over A equals to sine B over B. Okay, and then let's fill in the correct labeling. So angle A, it's QPR, and side A, it's 8.2. Angle B, it's 26. The opposite side, it's 5 centimeter. All right, so the next thing is we're going to do a cross multiply. So that's quite easy because if you're finding sine angle QPR, we will just do this first. Take 5 times sine QPR, and then your equal sign remain the same in the middle. And then after that, do the other side. So let's do the first side first, which is 5 times sine angle QPR equals to 8.2 times sine 26. All right, and then the next thing is that you can divide by 5 throughout to find angle QPR, which work out to be 0.7189. Right, please use at least 4 significant figure or 4 decimal places for accuracy. So angle QPR will be just sine inverse 0.7189, which work out to be 45.96 degree. Okay, so there's a questions that I need to ask. What do you think the questions I need to ask? Correct. So from the diagram, the angle QPR is an obtuse angle. But the answer you're getting, this answer here, clearly is not an obtuse angle. Right, so how am I going to make use of what you get to get an obtuse angle? Can you recall any concepts we have learned? How about the trigonometric ratios of the obtuse angle we have learned earlier? Yes, so we've learned earlier on that sine theta, all right, the trigonometric ratios of an obtuse angle, we learned earlier on that sine theta is equals to sine 180 degrees minus theta, right? What it means is that if you have an angle, if you let theta equals to 30 degrees, let's say, so your sine 30 is half, and then your sine 150 is also half. All right, so for the ratio half, there are two possible angles for your theta, 30 or 150. So therefore, to find the obtuse angle QPR, you just need to take 180 minus your acute angle, right? And you get 134.0 degrees. For angle, it's to express the 1 decimal place for final answer. And yes, we're using this concept. Okay, so that it's done ready for angle QPR. All right, so we still have to find the length of PQ. So how do we go about finding the length of PQ? Okay, so before we find the length of PQ, we will need this particular angle. Right, so which is rather easy because you've already found angle B, you already found angle A. So you just use 180 minus 26 minus 134.04. Please do not use 134.0 because your answer will not be accurate. Therefore, if you look at my solutions, I always have one that is expressed to 2 decimal places, okay, so that I can use it in the intermediate workings. And then I'll get angle QRP to be 90.96. Can you see? Again, also 2 decimal places for the in-between answer. All right, so what's the next step? Okay, let's write down the formula again. So that will be, yes, draw the arrow. This is exactly what I need to find. Okay, so is there a particular reason why I use 26 instead of angle A? Why do I use 26 instead of angle A, which is 134.04? Yes, because 26 is an exact value. Of course, you can use 134.04 also, right? No problem. It's just that 134.04 is estimated value, whereas 26 is the exact value, right? So it's kind of I don't know, like easier to use an exact value than estimated value, right? You don't need to put point, whatever. You see, it's just 26. Okay, so write down the formula. So that will be sine 26 over 5 equals to sine 19.96 over PQ. So we do the cross multiply again. Divide both sides by sine 26. And basically just use your calculator to work it out. And you will have PQ to be 3.96. All right, so the values of PQ is 3.96. All right, so here I would like you to look at the diagram. All right, and I'd like you to look at the size of the angles. How is the size of the angles that it's related to the size of the opposite sides? All right, so if you look at this triangle PQR, right, which one is the longer side? The longer side is PQ, which is 8.2, right? And the longer side, can you see, is actually opposite the biggest angle because your angle QPR is the biggest here, which is 134.0. Okay, and if you look at the shorter side is 3.96, right? And that is opposite the smallest angle, which is 19.96. Okay, why am I doing this? It's because sometimes in the questions, they will ask you to find for the largest angle. And how do you know which one is the largest angle? Yes, so the largest angle will be the one that's opposite the longer side. Okay? Okay, let's look at another questions. All right. This will be the last questions we're doing. All right. So bear with it. So again, we're given a triangle, blah, 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 with all the information given. And here you're specifically told that the angle ACB must be obtuse. Okay? So for this question, it's easier than the earlier one. The earlier one, you're not told whether angle ACB is obtuse on the cube. So therefore, you can have two possibilities, right? Sometimes, not all the time, you have two possibilities. We call that an ambiguous case. Okay? In this case here, you're specifically told that ACB is obtuse. So it makes our life easier. Right? So first thing first, let's draw a triangle. Okay, let's put in all the important data. All right. So the first step is to just label the angle and the sides properly. Okay. The other one. All right. What's the next thing? Yes, we do a cross multiply. Okay, came out very fast. So we do a cross multiply. By now, you should be very proficient in doing the cross multiply, that kind of thing. That's why it came out very fast. So we just do a cross multiply and then divide by both sides by 7.1 and then sine inverse your 0.9929 to get 83.16. Yes, again, 83.16 is an acute angle. It's not an obtuse. So what do we do? Yes, the concept is similar to what we have done earlier on in the practice question. We just apply this trigonometric ratio of an obtuse angle. Okay, where sine theta is 180 minus theta. So therefore, your angle ACB just be 180 minus 83.16, and that gives you an obtuse angle, which is 96.8 degrees. Okay, so that's first part. So how do you go about finding the second part, the length of BC? Yes, this is very similar to the earlier one we did. So after finding your angle ACB, angle AB, ACB and ABC, you can just find BAC to be 180 minus 46 minus 96.84. Again, take note of the value that I use here. I do not use 96.8, I use 96.8 for better accuracy. Okay. And then the next thing is, of course, use the sine rule again, which is sine 37.16 over BC. If you draw another arrow there from here to here. Okay. And then do a cross multiply and then divide by both sides by sine 46, and you get BC to be 5.96. So this question is more like a revision questions for you because it's similar in concepts to the earlier one. All right, let's do a summary. Right, we're going to see which situation where you can use the sine rule and in which situation we cannot use the sine rule. Okay, let's start off with the situation that we can use the sine rule. Right, so if you're given two angles as demonstrated there, okay, and one side of a triangle, you can use the sine rule. Right, or right, you're given two sides and a non-included angle. Non-included angle, okay, what is the included angle? An included angle is angle that's wedged between the two sides. All right, so this is called an included angle, this one, okay, right, it's called an included angle. So you can only use the sine rule when the angle given is not an included angle, okay, as shown here, right? So that's one situation where you can use the sine rule. All right, so in what kind of situation you can't use the sine rule? Yes, given two sides and an included angle, right? There's no way you can use the sine rule because too many unknowns. Yep, all those things are the one that not given to you, therefore you can't use the sine rule at all. Right, so can you think of any other examples where you cannot apply the sine rule? All right, so this slides will end this video here. Okay, so this basically just provide you with the basic concepts of how you can apply the sine rule. So if you want to do more practice, just look out for the next video where we will solve problems, using the sine rule.